Hello everyone, welcome back to my YouTube channel after a long gap. So in this video, without wasting time, let's go for a subject name called electric motors. Module 1, a continuation part of whatever I uploaded a previous videos. So just a glance like whatever I uploaded in a previous videos. So just look into here, the videos that I explained in the previous playlist called DC motor. That is a working principle of DC motor. I explained. You just go through the playlist, you'll get to know. Similarly, I explained about torque equation, back EMF, and significance. You can easily understand these concepts. So once after this significance of back EMF, the easy points to understand the concept. At the same time, you can go for the classification of different types of DC motors and also torque equation, very important. We just go through these all in a previous video in my playlist called electric motors. Then explained about types of DC motors, DC series, DC shunt, and compound DC motors, in that short shunt and long shunt DC motors, and also explained cumulative and differential, then torque speed equations, the relations. With the help of these relations, explained about characteristics of DC shunt motor and DC series motor, that is a torque armature current characteristics, as well as speed armature current characteristics, and also explained about speed torque characteristics of DC shunt motor as well as DC series motor. So you'll get to know all the points from this. Apart from that, also explain the types of motor, that is a characteristics along with applications of DC motor explained, and characteristics of compound DC motor. So in this video, let us come back to the video. So in this video, I'll explain about speed control of DC motor. There are two different types of DC motors you can use for the speed control. The first one is a DC shunt motor, other one is a DC series motor. So as per video syllabus, there's no series motor speed control, I think. So that I'll explain speed control of DC shunt motor. Before that, few factors you need to understand and you need to adopt to know about before going through the concept. You just have to know these factors. So what are those factors? So the factors are nothing but, so here you can see the relationship between speed and back EMF along with a flux, that you should know. Okay, the relationship between speed and flux along with the back EMF, as we all know, back EMF equation is given by EB equals to phi Z N P divided by 60A. Everybody knows. Okay, so that this parallel path flux is variable, number of conductors are constant, and also this Z is constant, this number of pole is constant, and this number of parallel path is constant. 60 is constant. With refer of that, you can say it as EB is directly proportional to phi and n. With the help of this, you can write speed is directly proportional to EB and inversely proportional to phi. EB means back EMF of different DC motors, the equation which depends on type of DC motor. If it is a DC shunt motor, V minus IARA, that is back EMF, and flux is constant. In case of DC series motor, flux is constant, is nothing but flux is directly proportional to current flows to the shunt field winding, ISH. Therefore, you can see the factors. N is directly proportional to EB, inversely proportional to phi, whereas EB is V minus IARA and flux is constant, that is directly proportional to ISH. So now these all you have to consider by considering Z, that is a number of conductors, number of poles, armature, a number of parallel path as a constants. But the value of armature resistance and the series field resistance RAC, that will be very small. so that a drop across that is also small whenever if you compare with the applied voltage. Hence, the voltage drop equation or else voltage drops of these two, that is a series field winding and armature winding drops, that we can neglect in some cases. By neglecting this EB, that is a IARA drop, you can get N is directly proportional to V and inversely proportional to flux phi, whereas V equals to EB. Okay. Therefore, the factors which are affecting the speed of DC series motor, DC series or shunt motor, you can see. So it is the flux is the main factor that will be affecting. So that phi and voltage across the armature and also applied voltage, these are the factors which will be affecting to the DC motor. So that these are the variable quantities. By varying these factors, you can vary the speed. So that depending upon these factors, the various methods of speed control. One is changing the flux, other one is changing the armature path resistance, that is changing the drop across resistor, drop across armature, and also changing the applied voltage called voltage control method. So I hope you got to know the points. So only you are playing with N is directly proportional to EB, inversely proportional to flux. So that the first speed control technique in DC shunt motor I'm considering now, that is a flux control method. Flux control, the word itself says, by controlling the flux, you can control the speed. So that you should know some relationships, that is N is directly proportional to EB. This is a shunt motor, remember, inversely proportional to flux phi. This phi is controlling to control the speed. If the flux which is controlled, speed is controlled. If the flux increases, speed decreases. If the flux decreases, speed increases. Means you have to control the flux. Therefore, what you can do, you can see the circuit diagram, flux control. DC shunt motor as a normal DC shunt motor. To control flux, what they are doing, they are adding one rheostat variable resistor. They are added one variable resistor which is connected in series to the shunt field winding. That is, for RSH, they were connected one variable resistor in series just to control the current flowing through the field winding. So what happened before start, after start of the rheostat? Before start, after start is nothing but at start, rheostat is in minimum position. So now we can consider. So as indicated by speed equation, you all know speed equation is nothing but N is directly proportional to EB and inversely proportional to flux. As indicating this speed equation, the speed is inversely proportional to the flux. This N is inversely proportional to flux. Therefore, this flux is depending on current flowing through the shunt field winding. Therefore, this flux is directly proportional to ISH. I hope you're getting point. Okay. Therefore, this flux can be controlled by controlling the ISH. This ISH you can control. ISH means current flows to the shunt field winding. This ISH you can control by adding one resistor, variable resistor in series to it. Okay, that is what you can call it as flux control method. Flux control method means a variable resistor is connected in series to the shunt field winding to control the current flowing through the shunt field winding. With respect of that, you are controlling the flux. With respect of that, you are controlling the speed. That's it. It's a very simple concept. Okay. So now what happened? Now we can see. So at the beginning means before what happened before the rheostat is in minimum position. Start means minimum. At the beginning, the rheostat is in minimum position, that is indicated as a start. So if the rheostat is minimum means it allows maximum amount of current that flows through the field winding, means by applying the constant supply voltage, a constant current which is flowing through the shunt field winding, so that rotor means this armature which rotates in a constant speed, so that at beginning you can observe the supply voltage is constant is nothing but rated value. When the rheostat is in minimum position, if you are applying the rated value of current, sorry, rated value of voltage, current flowing through the shunt field winding is also maximum because the rheostat is in minimum. You know the relation R is inversely proportional to current. So minimum means if resistance is minimum means it allows maximum amount of current that flows to the shunt field winding, that is rated current. The rated current is flowing through the shunt field winding whenever if you're applying the rated voltage, so that the motor which will be runs at a rated speed. It's a very simple logic. So now what you are doing, you start to increase the value of the rheostat. So if you're increasing the value of rheostat means, you know that rheostat is nothing but resistor which is inversely proportional to ISH. If you are increasing the value of rheostat means current flowing through a shunt field winding is decreases. Getting my point? If you increase the value of rheostat, current flowing through the shunt field winding is decreases. If current flowing through the shunt field winding decreases means this ISH is directly proportional to flux. If ISH is decreasing means flux is also decreases. If flux decreases means the speed is inversely proportional to flux. If the flux decreases, the speed of DC shunt motor which is running more than rated speed means it runs in a maximum speed, that is a more than rated speed. So before that, whenever the rheostat is in minimum position, constant supply voltage apply ಮಾಡ್ತೀರಾ. Rheostat minimum position ಅಲ್ಲಿ ಇರೋದಕ್ಕೆ it allows maximum amount of current. ಅದಕ್ಕೆ current flowing through the shunt field winding ಕೂಡ ಏನಾಗುತ್ತೆ rated value, rated voltage apply ಮಾಡ್ತೀರಾ. shunt field winding ಅಲ್ಲಿ rated current flow ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಮೋಟರ್ rated speed ಅಲ್ಲಿ rotate ಆಗುತ್ತೆ. ಆ ಸ್ಪೀಡ್ ನ ನೀವು ನಾರ್ಮಲ್ ಸ್ಪೀಡ್ ಅಂತ ಹೇಳ್ತೀರಾ. ಅದೇ ತರ ನೀವು rheostat ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಕೊಂತ ಬಂದಾಗ ಏನಾಗುತ್ತೆ current flowing through the shunt field winding decrease ಆಗ್ತಾ ಬರುತ್ತೆ, and current is directly proportional to the flux, so that flux produced in a shunt field winding ಏನಾಗುತ್ತೆ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಬರುತ್ತೆ. ಅವಾಗ ಸ್ಪೀಡ್ ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾ ಬರುತ್ತೆ, ಯಾಕಂದ್ರೆ ಸ್ಪೀಡ್ ಫ್ಲಕ್ಸ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಇರುತ್ತೆ. That is what you can observe. See, then R is increased. If you increase the resistance, current flowing through the shunt field winding decreases, hence flux is also decreases. As you all know, N is inversely proportional to flux. Speed of the motor that will be increases beyond its rated value means more than rated speed, means you can control the speed for more than rated speed in case of flux control method. That you should keep in your mind. Therefore, by this method, speed control above the rated value is possible, as you can see in this graph. If you plot a graph speed versus flux, initially for the rated value of current, the speed is rated speed, that is nothing but normal speed. So later on what happened, you are going to increase the value of resistance so that the value of current is going to decrease, therefore speed is going to increase, whereas speed is inversely proportional to flux. This flux is directly proportional to ISH. If you decrease ISH, flux decreases, speed increases. Why ISH is decreasing? Because you are increasing the value of RSH, that is R additional resistor, that variable resistor. Okay, this is what a flux control. In Kannada, you can, if you want to understand in Kannada means it's very simple. Speed ಯಾವಾಗಲೂ ಬ್ಯಾಕ್ EMF ಗೆ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಇರುತ್ತೆ, ಫ್ಲಕ್ಸ್ ಗೆ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಇರುತ್ತೆ. ಸೊ ಇದ್ರದ್ದು ಲಾಜಿಕ್ ತುಂಬಾ ಸಿಂಪಲ್. ಫ್ಲಕ್ಸ್ ಕಂಟ್ರೋಲ್ ಮೆಥಡ್ ಅಂದ್ರೆ ಫ್ಲಕ್ಸ್ ನ ಕಂಟ್ರೋಲ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ. ಹೆಂಗೆ ಕಂಟ್ರೋಲ್ ಮಾಡ್ತೀರಾ? ಒಂದು ರಿಯೋಸ್ಟಾಟ್ ನ ಫೀಲ್ಡ್ ವೈಂಡಿಂಗ್ ಗೆ ಸೀರೀಸ್ ಕನೆಕ್ಟ್ ಮಾಡ್ಬಿಟ್ಟು ಫ್ಲಕ್ಸ್ ನ ಕಂಟ್ರೋಲ್ ಮಾಡ್ತೀರಾ. ಸೊ ರಿಯೋಸ್ಟಾಟ್ ಮಿನಿಮಮ್ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ಇಟ್ಟಿರ್ತೀರಾ ಇನಿಷಿಯಲಿ. ಅವಾಗ ವೋಲ್ಟೇಜ್ ಎಷ್ಟು ಅಪ್ಲೈ ಮಾಡ್ತೀರಾ? ಸಪೋಸ್ ಇಫ್ ಯು ಅಪ್ಲೈಂಗ್ ಸಮ್ 200 volts, ಕಾನ್ಸ್ಟೆಂಟ್ ಸಪ್ಲೈ ವೋಲ್ಟೇಜ್ ಅಪ್ಲೈ ಮಾಡಿದ್ರೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಕರೆಂಟ್ ಫ್ಲೋ ಆಗ್ತಾ ಇರುತ್ತೆ ಶಂಟ್ ಫೀಲ್ಡ್ ವೈಂಡಿಂಗ್ ಅಲ್ಲಿ. ಅದರಿಂದ ಕಾನ್ಸ್ಟೆಂಟ್ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ಮೋಟರ್ ರೊಟೇಟ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಅದೇ ನೀವು ರೆಸಿಸ್ಟೆನ್ಸ್ ನ ಜಾಸ್ತಿ ಆರ್ ವ್ಯಾಲ್ಯೂ, ಅಡಿಷನಲ್ ರೆಜಿಸ್ಟರ್ ವ್ಯಾಲ್ಯೂ ನ ಜಾಸ್ತಿ ಮಾಡ್ಕೊಂತ ಹೋದ್ರೆ ಏನಾಗುತ್ತೆ, ಕರೆಂಟ್ ಫ್ಲೋಯಿಂಗ್ ಥ್ರೂ ದ ಶಂಟ್ ಫೀಲ್ಡ್ ವೈಂಡಿಂಗ್ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಕರೆಂಟ್ ಕಡಿಮೆ ಆದ್ರೆ ಫ್ಲಕ್ಸ್ ಕಡಿಮೆ ಆಗುತ್ತೆ, ಯಾಕಂದ್ರೆ ಕರೆಂಟ್ ಮತ್ತೆ ಫ್ಲಕ್ಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್. ಫ್ಲಕ್ಸ್ ಕಡಿಮೆ ಆದ್ರೆ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ, ಯಾಕಂದ್ರೆ ಫ್ಲಕ್ಸ್ ಮತ್ತೆ ಸ್ಪೀಡ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್. So in this method you can control the speed which is above the rated value. Okay, so this is about a flux control method. Only the speed can be increased up to twice its rated value. If the speed is 1500, you can control till 3000 rpm. Keep that in your mind. Advantages. This provides a relatively smooth and easy control, and speed control above the rated speed is possible, and this is economical and efficient. Coming back to the disadvantages, speed control below the rated speed is not possible, as flux can be increased up to its rated value. That is one disadvantage. Means you can only control the speed which is above the rated speed. And the second one is, as flux reduces, speed increases, but high speed, that will be making the motor operation unstable. There is a possibility of damaging the winding. Okay, and these are the advantages and disadvantages. Okay, and one more method, that is armature voltage control method, or you can call it as rheostatic control method. So in case of flux control method, you can control the flux by controlling the current flowing through the flux. That current is controlling with the help of resistor or a variable resistor, which is connected in series with the field winding. So here what happened? In case of armature voltage control, means you should consider armature. So there you are connecting rheostat is in series with a shunt field winding. Here you are connecting rheostat is in series with the armature. You can observe only one difference. You can easily remember the circuit diagram. To the armature rheostat which is connected in series. Clear? So here what happened? If the rheostat is in minimum position, if this rheostat is in minimum position, so it allows maximum amount of current that is flowing through the, or else the voltage across the armature is constant by applying the rated voltage. Rheostat in our minimum position ಅಲ್ಲಿ ಇದ್ರೆ rated voltage apply ಮಾಡಿದ್ರೆ shunt field winding ಅಲ್ಲಿ rated current flow ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ rheostat minimum ಇರೋದಕ್ಕೆ ಈ armature ಇದೆಯಲ್ಲ ಇದು rated speed ಅಲ್ಲಿ rotate ಆಗಕ್ಕೆ start ಆಗುತ್ತೆ. Means the speed of the armature is rated. When you increase the value of rheostat, ಇವಾಗ ಏನಾದ್ರು rheostat value increase ಮಾಡ್ತಾ ಬಂದ್ರೆ voltage drop divide ಆಗ್ತಾ ಬರುತ್ತೆ. So there will be drop across this rheostat plus a drop across armature is going to decreases. If the drop across armature is decreases, means this EB is going to decrease. If the EB is going to decrease, means speed is directly proportional to EB. As you all know, if EB decreases, speed is also decreases. Means you can control the speed which is below the rated speed. That's what you can call it as armature voltage control method. So that you can see here, the field winding is excited by normal voltage, means you are not connecting anything to the field winding. So that if you apply the rated voltage, rated current is flowing through the field winding, so that motor runs at a rated speed. You can call that as normal speed. Okay, initially rheostat is in minimum position, rated voltage gets applied across the armature because there is no register. Maximum amount of current that flows, maximum amount of speed you can get. That is a rated speed. Similarly, for a given load, if you increase the value of rheostat, IA that will be same because IA is same because it is a series connect, but voltage drop across R and voltage drop across rheostat and voltage drop across armature will be dividing, so that if you increase the value of rheostat, voltage drop across the armature is going to decrease. If voltage drop across the armature decreases, speed is also going to decrease. That is below the rated speed. That's why by varying this extra resistance, you can control the speed which is below the rated speed. In case of flux control method, you can control the speed which is above the rated speed. In case of armature voltage control method, you can control the speed which is below the rated voltage. Only one difference. Okay, very simple to understand. So ಅಲ್ಲಿ shunt field winding ಗೆ rheostat ನ series connect ಮಾಡ್ತೀರಾ, ಇಲ್ಲಿ armature winding ಗೆ rheostat ನ series connect ಮಾಡ್ತೀರಾ. Okay, graph you should remember. So The third method is potential divider method. You can see potential divider means you can add one potential divider which is across the supply, and it is having three position. One is a central position, other one is minimum and maximum. Means if you vary the value of this resistor, drop across the armature is varying. If you vary this, drop across armature will be varying. If you increase the value of resistance, voltage across armature increases. If you decrease the value of R, voltage across armature is decreases. If voltage is varying, voltage is decreasing or increasing, speed is also varying because EB is directly proportional to N. Keep that in your mind. That's why I can see here when the rheostat position is at start means minimum. Start means resistance is 0. Therefore, voltage across armature is also 0 at start. Okay. If the voltage across armature is 0 means EB is directly proportional to N, so that speed is also 0. That's it. Similarly, next, if the rheostat which is moving from start position towards maximum means if the rheostat which is increasing, what happen? Voltage drop across this armature is also going to increase. If voltage drop across the armature is going to increase means speed is also going to increase. Therefore, as rheostat moves towards maximum point, the voltage across the armature increases, hence speed is also increases. So whenever it reaches the maximum point, whenever it reaches the maximum point, at this point, voltage drop across armature winding is constant, say that a rated voltage, hence motor starts to rotate in a rated speed. You can see, in the graph here. The motor requires some voltage. The motor requires some voltage to stop so that initially the voltage is minimum, speed is minimum initially when rheostat is at start. When rheostat is at start, voltage across armature is 0, hence speed is also 0. When you increase the value of rheostat, voltage drop across armature is going to increase, hence the speed is also going to increase till where? Till the rated speed. Till rated speed, it will increase. So in case of flux control method, you can control the speed which is more than rated speed. In case of armature voltage control method, you can control the speed which is below the rated speed. Here you can increase the speed till rated speed, then you can control initially. Okay. So this is about a potential divider method. Okay. And you can see the advantages. Easy and smooth speed control can below normal speed is possible. In case of flux control method, it is not possible. In case of voltage control method, that is armature voltage control method, it is possible. And in this method, rheostat is used as a starter. If rheostat is 0, voltage 0, speed 0. If rheostat is maximum, voltage maximum, speed maximum. But here the power loss is more. Therefore, the rheostat required is of large size and capacity. And here the speed above rated is not possible due to the large power losses. What happened? The method which is expensive and it looks like a wasteful and it takes a less, or else it will give you the less efficient output. Okay, so that rarely they will use potential divider method, but maximum time they will use flux control method as well as armature voltage control method. Flux control method to control the speed which is more than rated speed. Armature voltage control method which is used to control the speed that is less than speed. Okay, this is about a theory part. Coming back to problem. So whenever solving the problem of speed control method, you need to follow these steps. The first step is identify the method of speed control. Identify the method of speed control. That is, in which winding of the motor the external rheostat is connected. If the rheostat which is connected in series with the shunt field winding, then it is armature voltage control method. Sorry, uh, flux control method. If the rheostat which is connected in series with the armature, then you can call that as armature voltage control method. You have to identify which type of speed control it is. Then you can use the relation of torque equation, that is torque is directly proportional to phi and Ia, and determine the values of new armature current. They will give Ia1, you need to find the value of Ia2. They will give T1, T2, Ia1, you need to find the value of Ia2 with the help of this relation. T1 by T2 equals to Ia1 divided by Ia2. You can get the value of Ia2. Okay. Then use the speed equation. With the help of this equation, you can find the value of unknown back EMF. Either you can get N1, then you can they will give N1 and EB1. They will ask you to find EB2. Okay. So this is a calculation method. So you need to follow this. If possible, I'll post the video regarding solving the problem also. But the thing is that it's very interesting concepts, so that you should know about this flux control method, voltage control method, and rheostatic method. Okay. For any doubts, for any clarification, feel free to write in a comment box. And thank you so much for watching this video. If you really like this video, kindly like and share maximum, and don't forget to subscribe. Thank you so much.